Here's another example of finding a derivative when we're already given a polynomial, working backwards a little bit. This is f prime 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 of 0. We want the third derivative at x equals 0 for some function f that we don't have. But what they give us is they give us what the Taylor polynomial would have been, or the Maclaurin in this case because it's centered at 0. So I only care about this third derivative, so I'm only going to look at the third degree term, which looks like is this, negative 5x cubed. And thinking back to, well, how did they get that term in a Taylor polynomial? So they must have used the Taylor formula. And the formula for the Taylor series for the third degree term would have been the third derivative at 0, because it's Maclaurin, x cubed over 3 factorial. And when they used that formula, they must have gotten negative 5x cubed. So I'm going to set those equal. I'm going to say this formula should have resulted in negative 5x cubed, and I can kind of work backwards to see what would this number have to have been to get negative 5. So I'm going to solve this equation. It's just an algebraic equation at this point. They both have an x cubed, so I can cancel that out. And I'm left with the third derivative at 0 divided by 3 factorial equals negative 5. So now I'm going to multiply both sides by 3 factorial and get that the third derivative at 0 must have been negative 5 times 3 factorial, which is negative 5 times 6, which is negative 30, or answer choice A.